All right, for FRQ number 6 right here, we have a continuous function, and we have the graph of f, and we have g being the function 2x plus the integral from -2 to x of f of t dt. Part A says find g of 0 and g of -5. So to find g of 0, we are just going to plug in 0 and see what happens there. So that's just going to be 2 times 0 plus the integral from -2 to 0 of f of t dt. Well, oh, this is not going to be fun. -2 to 0 here. She is a trapezoid. Very cool. So then we get g of 0 is equal to 0 plus 1/2. Your bases are going to be 2 and 1. And then your height is going to be 2, which gives us 3 as our answer. G of -5. So this becomes 2 to the -5 plus the integral from -2 to -5 of f of t dt. -2 to -5 is here. Ooh, Jesus. Here. And then we'll see where that takes us. So we want to see the difference here. Not fun. Now, I am going to do a little switcheroo here. That's going to be a minus. And then this is going to be a 5. It's going to be a 2. And then we are going to see what that area is. Oh, this is not going to be fun. All right, this right here is going to be 1/2, 1. Your height is 2, so that's just 1. Then this right here is going to be 1/2, 2. Looks like your height is 4. Let's see, so that gives us 4. Since it's below, that's going to be a -4. So then we get 1 minus 4, which gives us a -3. So then we get -10 minus -3, which gives us -7 as our answer. Ooh, that was a mess. All right, so then we want part B, where it says find g prime of x in terms of f of x. So g prime of x is just 2 plus f of x times the derivative of x, which is just 1. Now, you have probably seen that all 6 problems so far that we've done, our upper variable has always been x. Now, is it always going to be the case? No. It's just that it's always been an x so far. So on your FRQ, on your test FRQ, you might see a 2x, and then you'll have to take the derivative of 2x, and then multiply that with FTC part 2. But anyways, you also want to find g double prime of 4 and g double prime of -2. So we got to take the second derivative here, which gives us f prime of x. So then that gives me g double prime of 4 being f prime of 4. Now 4 here, 1, 2, 3, 4, is just the slope of this lovely line right here. And the slope of that lovely line, let's see, we could go down 3. 1, 2, 3. Down 3, right 3, which gives us a slope of -1. Now for g double prime of -2, let me just erase all of this. -2 is right here. Now, if I want to find the derivative, aka the slope here, you'll notice that this slope does not exist, and then you have to justify why it does not exist. Well, if you look at your left-hand limit, because the limit as x approaches -2 from the right of f prime of x, that is positive, and the limit as x approaches -2 from the right, that is negative. And because they don't match up, we know that g double prime of -2 does not exist. Very sad. All right, for part C, it's asking us when is g concave down? Give a reason for our answer. Well, g is concave down when f prime of x is less than 0. Well, plot twist. I can't say that because I have the graph of f. So you have to tell me in terms of f what's happening. So in this case, in order to get g double prime of x being f prime of x, and this is f, I need to say that g concaves down when f is decreasing. And you can see that I'm connecting whatever they give me, in this case the graph of f, in terms of my answer. So f is decreasing from -2 to 0 and 2 to 8. All right, last one. We have this function right here, and we want to find h prime of 1. We got to figure out the derivative, so just use chain rule here. And then we got to plug in 1. That's just 1. Well, yeah, 1 times 1 is 1. So that's 3 times g prime of 2. All right, now here's the thing. G prime of 2. We need to look back at our original function here, or probably here, this might be better, to figure out what g prime of 2 is. So g prime of 2 is going to be 2 plus f of x. F of 2 is 3 right here, which means that g prime of 2 is 5. So then I could say 3 times 5, which is equal to 15. That is h prime of 1. All right, in the next video, we are going to do FRQ 7, and that is just more graphical, not graphical, analytical analysis.